You do it every single day. You sit down at your computer, type in a password, and boom, you're in. It feels so simple, right? Almost instant. But behind that little login box, there's this whole hidden world of rules, challenges, and digital gatekeepers, all working to figure out who you are and what you're allowed to see. So what is really going on in those few seconds? How does this massive digital universe know for sure that it's you and not somebody else trying to get in? Okay, let's pull back the curtain on this, because the answer is all about how your digital identity is managed.
At the very heart of it all is this concept, identity and access management, or just IAM. You can think of it as the master security guard for any organization. It's the bouncer checking your ID, it's the receptionist giving you a keycard, and it's the security system deciding which doors that keycard can actually open. It's the whole shebang.
All right, so you're past that first gate, you're logged in, but your journey's not over, not by a long shot. Now the system has to figure out what you're actually allowed to do. Which keys to the kingdom do you get?
Here's a situation I'm pretty sure we've all run into. You go to open a general company-wide memo and it opens right up, no problem. But the second you try to click on a sensitive file like HR salary info, bam, access denied. So what gives? You're logged in, right? Well, it's because there are all these different rule books being used behind the scenes.
So this slide breaks down the three main ways systems figure this stuff out. First, you've got mandatory access control, or MAC. Think of this like military security clearance. The rules are super rigid, they're set by the system admin, and that's that. Then you've got discretionary access control, or DAC. Here, the power is in your hands. If it's your file, you decide who gets to see it. Simple. But the big one, the one you'll see almost everywhere in the workplace, is role-based access control, RBAC. This is where your permissions are tied directly to your job title. Are you an HR manager? Great, you can see the salary files. You're not? Sorry, that door stays closed.
Okay, so we've got the rules down. But getting access isn't just about rules. It's about proving you're the right person in the first place. And these days, that takes a whole lot more than just a simple password. So how do you prove it's really you? Well, modern security is built on a few key factors. There's something you have, like a physical smart card or a token. There's something you are, like your fingerprint or your face. And then there's something a little different, a digital certificate. This acts like a secure passport for your device, proving to the network that your laptop is trusted and allowed to connect in the first place.
Now, that something you are category, biometrics, is really fascinating because it comes with this built-in puzzle. How do you design a system that's secure enough to keep bad guys out, but not so paranoid that it accidentally locks you out?
And this right here perfectly illustrates that puzzle. It is a constant balancing act. On one side, you have the false acceptance rate, or FAR. That's the nightmare scenario where an imposter gets in. On the other side, you have the false rejection rate, or FRR, which is just plain annoying. That's when the system fails to recognize you, the actual legitimate user. The sweet spot, the goal for any good biometric system, is to find that perfect balance where both of these error rates are as low as they can possibly be. That's the sign of a system that's both secure and actually usable.
Of course, the technology for this stuff has come a long way. In the early days, we had protocols like PAP. The problem? It sent your username and your password across the network in plain text. I mean, can you believe that? Anyone listening in could just snatch it right out of the air. Then came CHAP, which was a huge leap forward. Instead of sending your password, the server sends a unique challenge. Your computer uses your password to encrypt a response and sends it back. Your actual password never leaves your machine. It was way more secure. But even CHAP is considered pretty old news now.
So what do we use now? Well, in a lot of corporate networks, the answer is Kerberos. It sounds super complex, but just think of it like going to an arcade. When you first log in the morning, you prove who you are just once to get a master ticket. It's called a ticket-granting ticket. Now, for the rest of the day, instead of putting a coin in every single arcade machine, you just show your master ticket to get a specific short-term ticket for each game, or in this case, each application you want to use. You get to access tons of different services without typing in your password over and over again. It's the magic behind single sign-on.
Okay, so you're authenticated, you've got your access tickets, but how does your computer even know where to find the printer down the hall or the file server you need to connect to? For that, it needs the network's address book.
And that address book is called a directory service. It's basically this huge central database that keeps track of identity info for everything on the network. We're not just talking about users. We're talking computers, servers, printers, shared folders, you name it.
It is the single source of truth that lets your computer find anything it needs. Without it, a network would just be total chaos.
And you've probably heard of some of these before. The absolute giant in the corporate world is Microsoft's Active Directory, but you've also got popular open source options like OpenLDAP. Even Apple has its own version for macOS environments called Open Directory. At the end of the day, they all do the same fundamental job, keeping the network's address book organized and up to date.
So let's zoom out. We've been talking about a single login, a single user. But imagine trying to manage thousands or even millions of these digital identities. This isn't a one-time setup, it's a whole life cycle you have to manage.
And that's really the crucial point here. This goes way beyond just letting someone log in. It's about having clear, enforceable policies for creating an account when someone joins, changing their permissions when they move to a new role, and, maybe most importantly, disabling that account the very moment they leave the company.
A huge piece of this puzzle is the password policies we all know and love. There's a reason they're so specific. They demand a minimum length to make it harder for computers to just guess your password. They require complexity, mixing letters, numbers, and symbols for the same reason. They keep a history so you can't just keep switching back and forth between your two old favorites. And they often try to prevent you from reusing passwords, because if one website gets hacked, attackers won't suddenly have the keys to your entire digital kingdom.
But there's this really sneaky danger in all this called permissions creep. Here's how it happens. You change roles at your company. You get a whole bunch of new permissions for your new job, but nobody ever takes away your old ones. Do that for a few years, and you can end up with access to all sorts of sensitive stuff you have no business seeing. It's a huge security risk, and it completely violates the core security idea of least privilege, only giving people the absolute minimum access they need to do their job. And that's why regular account checkups are so critical.
And that brings us to the biggest headache of our modern digital lives, right? It's not just about one corporate network anymore. We have hundreds of accounts, social media, banking, shopping, you name it. It's an explosion of passwords. How in the world are we supposed to manage a single, secure identity across all these disconnected websites and apps?
Well, the answer lies in these protocols. They're the engines running behind those sign in with Google or sign in with Apple buttons we click all the time. SAML is a big one in the corporate world for this. But for the websites you and I use every day, it's usually a team effort between two others. Think of it this way. OpenID is like the bouncer at the club door. It just answers one question. Who are you? It confirms your identity. But once you're inside, OAuth is the one that says, hey, is it okay if this app accesses your photos on our behalf? It's all about permission. It answers the question, what is this app allowed to do for you? Together, they make that seamless sign-in experience possible.
So when you step back and look at the whole picture, from that simple login screen to a single identity that follows you all across the internet, it's pretty clear the way we define you online is becoming more powerful and way more centralized. It really makes you wonder, doesn't it? As our digital and real-world selves keep merging into one, who or what is going to be the ultimate gatekeeper of you?